What Bob is doing is taking a chemical analysis of a particular heat of metal. This happens with every heat of metal that we pour. This is a spectrograph where we put a solidified sample into the unit. Analysis is taken and a printout on the computer as to what the chemical elements are that we're looking for in that particular alloy. We have certified standards that we use on a daily basis to assure the accuracy of the machine, etc. These are standards that are maintained throughout the world so that if the material is made in this country or if it's made in some other country, there's still continuity and consistency as far as product is concerned. What we do is we buy ingot from a primary supplier. We have a primary material and a secondary material. The primary material is reduced from the bauxite ore and made into an ingot shape, let's say, and then we buy that product. Secondary material is material that a scrap dealer would buy, let's say, soda cans, screen doors, or whatever would be made out of aluminum product, and then it would be mixed together and melted, and consequently the result would be a secondary material. The difference between secondary and primary. We melt exclusively primary material at this facility in the 356 line, and the only secondary material that we buy is a 319 line that we get domestically. The majority of our metal is coming from Russia. As a matter of fact, for the last 4 or 5 years, our metal has been coming from Russia. After the analysis is complete, Bob will look at the numbers, etc. If there's any additions to be made to any of the elements, we have a graph that we will use, and we will add to a particular element that we want to increase, magnetite, strontium, whatever the case might be. And that is predicted or predicated on what is on the job instruction card for the job that is running at that point. The reason we add those materials to the metal before we cast it, and what you saw on the sample on the computer before we come into the lab, was so that we can take the metal, which in its natural form would have a linear formation as you see here, and by making the additions that we do to the metal, then we get a modified version as you see here. And that's what we're trying to achieve, that we get the optimum as far as mechanical properties are concerned, because of the fact that strength plays a big role on how the end result of the product is used, and that strength has to be assured. Chris is in the process now of pulling a test bar. We make many test bars to verify the strength of the particular part. You can see you'll see that move in a couple minutes. That is the actual chart on the right as to how strong this is going to be. This is a 1/2 inch test bar, ASTM standards. What he's doing right now is holding the points in place, because that will actually stretch to a given dimension before it breaks. And it's going to break right about now. All right, so that what we're able to do then is we're able to put that bar back together, and we'll be able to read how much it stretched before it broke. That's how we read our elongation, which is the ability for the metal to give as opposed to fracture, which is critical, especially in the electrical field that we make product for. A little bit ahead of ourselves, but as a secondary process to our metal, what we do is we go through a heat treating process, and we put these castings into what we call a T6, and we'll explain that further when we get into the heat treating area. But essentially, all our castings have to be certified, so that the order in which we certify that particular product is that test bars are put into the baskets in the heat treating furnaces. And before those castings are removed, the test bars are broken and verified for the mechanical properties before we are allowed to remove those and reprocess them for shipment. What we're doing here in our sand lab is we have 2 separate sand systems, and Betty is doing a sample analysis on the sand, where she is weighing out a specified amount of sand that would be put into what we call a 3-ram compactability. All right, she's going to put the sand into the go ahead, Betty, into the cylinder. That'll be placed on the compacting unit. That's a specified weight. That will ram 3 times. Then she'll be able to read a compactability number that you see here on the top. That tells us the ability for the sand to compact. Yes. Now the specimen sand will be placed into a tinsel machine. Our sand consists of a bentonite clay, of western and southern bentonite, and about 3% moisture, about 5% clay. You can see the sand fractured, and there's a magnet on the scale that tells us exactly how strong it was before it broke, which is about a green strength number of about 23.